Last session we saw example about configuration server. Just a minute, guys. Yeah. So we understand that when we implement application by following microservices or pattern, when we distribute scope into multiple smaller pieces, small size applications, maintenance will become difficult. Whereas in single application, all configurations, security, transactions, or logging, all cross-cutting services or extra add-ons, whichever you want to apply to your application, they will be simple because one single piece you have, one single application you have, so that you can easily apply that. But when your application has been splitted into multiple smaller pieces, maintenance will be difficult because as we divided them into smaller pieces, if you configure local properties, when you want to change them, change will become difficult. You should go to each and every application property if it is a common property. So across all the microservices, locally you configured it, and when you want to change it, you should visit each application and you should modify that. And if you apply security for each microservice within the application itself, when you want to do security related configuration changes, you should visit each application and you should do that maintenance changes there. Or if you want to apply logging, if you have separate log server or if you have a separate log file for each application, it will be difficult to monitor where the problem occurred because microservices may have dependency on other microservice. From one service to another service also your request may flow. In that scenarios, if something failed within single application, when we call from one class to another class, and if there is an issue, all the logs will be registered into same file so that we can able to see when the problem occurred and where the problem is. Monitoring also will be simple. But when I make a request to one microservice, from there if it go to service A, service B, service C, service N, somewhere it failed. We don't know where it failed. If we maintain local logs for every application. So instead of maintaining local logs or local properties configuration or local security, if we can centralize them, it is easy to maintain it. So one of its useful configuration is cloud config concept. So using this cloud config concept, you can have all your configurations in a central server. From there you can get it into your local. For that what we used, cloud config server dependency we have used, and we created a config server, and that config server can able to fetch properties from vaults or git or bitbucket. We saw so many configurations they given. If you have kind of azure vault, from vault you can get, or if you have simple git repos or bitbucket repos, from there also you can fetch it. Azure vault or aws, any cloud vaults if you have. So you can configure. I'm not sure about AWS. Yeah, maybe secrets. Yeah. In Azure, we can have Azure Key Vault, a service there we can register all our keys and values. Okay, so that it is not visible to others. If somebody wants to see what is that property, they can't directly see, but they can consume it. So some secrets, if you want to maintain, you can maintain them. If you don't have that Azure or AWS, if you have simple repository there, if you want to maintain, yes, you can maintain it. You can create your properties into your Git or a Bitbucket repo, and from there you can load it into your config server. And you can link your microservices with this config server. So all the properties, it will bring it into your application, whichever you have in the cloud, vault storage or Git or Bitbucket, all these properties, first it will get it into cloud server. From cloud server, it will load it into your local services. So just to load into our local services, what we have used. So this is what config server we created, and it is running in 8282 port number, and we given Spring Cloud config server with the Git, and the Git URI we given. This is the Git path. Here we have all our properties. So these properties are getting loaded from central repository. So you can consider this as a central repository configuration. So here admin can go and he can add his configurations or modify his configurations. For now, I have simple database configurations here for all my profiles. Dev profile, SIT, production. If you want to maintain in a single place, you can maintain. And these properties are getting loaded into this config server here first. In the first step, all the properties will be loaded into this config server, which is running in 8282. For this one, which dependencies we added? Simple Spring config server, Spring Cloud config server dependency we added here. So it will, to enable config server, we have used at the rate enable config server also here. So the config server job is bring the properties from that Git repo to local. Into this local server, it will bring them. So once you get it into local server, you should be able to consume across all your microservices. Once you get them into this config server, guys, if you are not speaking, go to mute. Yeah, that we will see. So once this config server is started, if you want to consume it, right, in the consumer end, you need to use in consumer projects. If you consider all your microservices, admin, seller, manager, for customer, you have search project, customer cart project, customer, payment service. You have different microservices. Across all these microservices, if you want to consume them, you need to use config client dependency. So first one which we saw is this is config server dependency, and this is config client dependency. So all your microservices are config clients because you are trying to fetch properties from the config server. So wherever you want to consume properties from config server in your client applications, right? Which means in your microservices you need to configure Spring Cloud Starter config. This is config client dependency. This is config client dependency. Okay. This is config server dependency. Spring Cloud config server, Spring Cloud Starter config. So wherever you want to use your configurations, right, from the config server, you need to add this dependency so that it can able to fetch that properties. What else we need to configure? Your config server path also. If it is running in some domain, you need to give the domain path here. So from there, it will connect with your config server and it will load all the properties here. And it will have all the environment properties. Whichever profile you want to activate for your local, that's up to you. You can put Spring Profile Active SIT. So for your application, it will fetch properties of SIT here. SIT properties it will consume. Basically, it will load all the properties here, and you are consuming SIT here. SIT properties into your local. So for that, what we did, we given simple bean class, and here we are trying to auto where URL, username, passwords in this controller, and just trying to printing them here, just to see whether that properties are really coming from there or not. So SIT properties. So this driver URL, username, password must come here into this client from this git to. First, it will come to your config server here. From this config server to config client into config client. Here we are auto wiring them using at the rate value. We are loading them. So you can start config server. So config server should be up and running always, right? Config server is a dependency for all your microservices. So all these microservices needs configurations from the server. So it should be started first, then you can start your local services. So config server is started. Now you can start your config client. Localhost 9090 slash get data. So it is giving us the properties, username, password, and the URL from here. Okay. So you can apply this to all your microservice in case if you don't want local configurations, if you want configurations from config server. Usually, right, a small application itself, it is going to have multiple microservices. A small requirement itself, if you take for each feature, if you implement, right, we can implement by module or we can implement by use case or by feature. Excuse me. So in case if you have a lot of microservices, it is really difficult to maintain properties in local, right? In case database configurations or database migration is happening. Excuse me, guys. JDBC URL. Why this URL is here? Okay, that we will see later. Okay. So here when you have microservices, that is okay. You can put any URL, RKill URL or whatever it is to connect with your database. Okay, it's part of your database configuration. Something XYZ. Just imagine this is something XYZ. Okay, not related to this config service. Something XYZ you consider URL is XYZ that you need to put here and load it into your application to connect with your database. Okay. Consider when you have lot of microservices. When you have a lot of microservices, initially in one of my project, we used MongoDB first, and we implemented almost 8 or 9 services. 8 or 9 services we used. Later we realized that there is some problem with the license, and we migrated it to some other vendor, database. So that time same database only, but from the other vendor, we procured it, and we have to do the changes. That time we used local configurations. Again, we visited all 8 microservices, and we did all the local changes. So if it is 8 or 9, it's okay. Still we can go and we can effort that change. We can go and change it in the local. But when you imagine a big application which is having, you know, 50 plus or 100 plus or 1000 plus microservices, it is really difficult you to visit each application and do the changes there. So as that is very difficult part, if you can centralize these properties in the next microservice project for one e-commerce, we implemented it there. We particularly used a vault concept. There they used a private vault. From the private vault, we used to fetch all the properties and we auto-wired in our local microservices, so that in case if they want to change any configurations, they need not to visit local microservices and they need to apply the changes here. Instead, they will do vault level changes, admins or DB admin or vault admin or Azure admin. When there is a change, when we inform the change to them, they will go to that vaults and they will do the changes whichever required, and that changes will be reflected into our applications as soon as they change. In case if you want to restart, you may restart your environments, or else there are some refresh listeners also available. So when you configure refresh listener, almost whatever changes it will do here, so that changes will be reflected into your config server immediately, and that will be reflected into your applications if you configure refresh listener. In case if you don't want to constantly listen refresh event, maybe you can restart your application, so new configurations will be loaded into your local. So it's always good practice to have a centralized config instead of having local configuration, so maintenance of your application will be simple as it is microservice, right? So the configurations need to be centralized, not in the local. So this is clear. Anyway, we could able to get it into our local service. Yeah. Yes, properties in case if you want to load specific application properties into your local, and if you want to maintain them there, you can do. Basically, no, 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 I got you. Yeah. So in case if you want to maintain all these application properties here with a separate properties file, if you want to maintain, right? Separate properties file or in single properties file, separate properties file if you maintain, you should load it. You should load it. We can use property loader. There is an annotation particularly to load the properties. Let's say property placeholder, property source. You can, I think property placeholder. There is another property source. I think property source. You can give your properties prefix here, class path. You can give property from the class path, or we'll see that. Okay, we can load, actually we can load specific properties file here in case if you want. From config, if you want to load that, I'm thinking whether I can able to refer directly. We should able to when we have multiple properties files. Yeah. Yes, you can. Oh, yes, yes. Yeah, yeah. If you specify the same key here, it will override. Let's say username is not this one which is coming from there. With same key, if you configure property in local, it will override. It will override the one which is coming from here. Yeah. Actually, her question is, yeah, in case if you want to maintain, different properties file for each microservice by using config service only. I don't want to configure all applications properties in one single properties file. For each application, if I want to maintain a separate properties here, how we can load them into our local. Usually when we have application properties, directly it is loading. Directly it is loading into this cloud config server, and from there we are referring it. If you have specific properties files, if you see config server, we can just config server git path here. We never specified any properties file name. So in case if you have multiple properties, maybe you need to link them all into this application properties. Let's say application one property. We'll see this, okay? I never thought of having that, but yeah, we can see this application one dot properties. If you have same way application two properties, you may need to link all them into application properties. For each microservice, if you have separate properties file, you can load these properties into application properties via application properties into config server. While loading into your local, using at the rate property source, at the rate property that source, right? We can give specific properties file whichever you want to load. So properties for each application, that we should see. But there should be possibility, right? We can have, we can link in, even in Spring XML also we can have multiple XMLs that we can club into one single XML by using XML import to tag. We have not discussed, but there is a chance that we can have multiple properties, and yeah, m- yes, multiple properties we can have, and we can integrate them together. Okay, so just imagine that there should be possibility. Okay, there should be must have way to load them. Okay, now, yeah, similarly, like how configurations you maintained centrally, your application access also you need to give via gateway. With one single point of contact, you should give your applications access. Otherwise, maintenance will become difficult here. Let's say you have multiple applications here, web application, mobile application. What else we can have? Some REST service also wants to call some REST client or any other web client, they want to call your backend microservices. So again, coming to backend microservices, I have multiple microservices. Each environment we will be having different server, so that we will be having different URL also. Different server means different IP number and port number. So consider you have admin service here for dev environment, seller, manager, customer. For your application, obviously you will be having multiple environments. Let's say you have one set of servers for development, and for SIT you have different set of servers, and you have UAT, prod. Imagine, just imagine when you have lot of environments, environment to environment we will be, what's that? Yeah, production. When we switch our, when we switch or when we deploy our microservices into a different environment, altogether different URLs also they will be having. When we run it in dev environment, we will be having dev server URLs and dev server port numbers. For SIT, we will be having separate SIT server, IP addresses and port numbers. For UAT, we will be having different domain URL, and for production, we will be having different domains. In case if we have web app, yeah, no, not about properties. Giving access to front ends or giving access to consumers. Okay, talking about gateway. Now here I have multiple environments, multiple microservices I have for each environment. Again, I have multiple microservices. So each application will be having a different URL. Each application is having a different URL for each environment. Here you will be having one URL. That URL will be changed here when it comes to SIT, UAT, production. So for admin service itself, we have four different set of URLs for seller, for manager, for customer. So 4 into 4, altogether 16 URLs we have here. For each environment 4, for all environments 16 separate URLs we have. 16 URLs you should share with your front end. 16 URLs you should share with your front end team, right? So your front end team, if they want to do the testing for dev, they need to integrate with the dev URLs and they should test it. So they need to connect with the dev services and they should test it. And if they want to connect with the SIT URLs, UAT URLs, production URLs. Same way, mobile UI also want to do the testing on all the environments. You need to share same 16 URLs to them so they can connect with your each application directly and they can test it. Yeah. So system integration testing takes place once your local development is done. Somebody should do the black box testing who is not a developer. He should behave like a end user and he should test your application. Whichever application you place into SIT, it should be a working copy. Like end user, he will test all the business cases. Hmm. Hmm. They, yeah, they may call, they may not call. It all depends on your application use case. Let's say if they are calling, they should check whether all that calls are working fine or not after your change. Your change should not break the existing flow, and as well as new flow also should work, right? So they do the entire regression testing one more time whether your change did break any existing functionality, or is it working fine or not. Somebody should verify before moving it to the prod, or else you do a mistake. Yeah. No, no, within the module it may work, but outside the module it may not work in some cases. Let's say you changed one property, you know that that property you changed, so that you will be verifying within your module. Wherever you have dependency, you changed it, but the dependency service may not have that changes. You may not informed them. So when they call, they will expect five properties. You are sending six properties, or they may expect six properties. You are sending five properties. Their use case may fail because properly we did not communicated them. When that will be identified, maybe in integration testing, when it go to SIT, so there we might realize, okay, because of this field not discussed with them, they may not adopted that change. So from their side, it is failing. So then we realize we do fix it. Yeah, of course. Between the features, you can say end user testing. Correct. Hmm. He will do end to end testing. End user before going into prod, we will be checking each and every flow. Yes, functional testing. Yeah, integration, all testing. All scenarios, all positive scenarios, negative scenarios, everything will be tested with junk. Yeah, yeah. Okay. So here earlier we realized the use case of config server. When you have local configurations, it is difficult to maintain the configurations. Similar way, when you have multiple microservices, just talking about four microservices with four environments, altogether 16 URLs I have. So in case if you have 100 microservices and four environments, 100 into 4, you will be having 400 URLs. You need to exchange that 400 URLs with your all your clients, web client or mobile client or any other REST clients, other third party clients. If they want to make if they want to make calls to your application, all your environment URLs you should share them. During their development, they will connect with the dev server. During their SIT testing, they will connect with SIT. For UAT, they will connect with UAT. For production, they also will connect with production server. So instead of sharing this many URLs, instead of directly giving access to URL, the problem is 16 URLs you have here. In future, if you change any configurations here, again, if you change any URLs here, if you do any change in the URL, you need to inform that URL to your clients. You need to inform to all your clients, and they should adopt that change. Just URL change. I want to make a URL change. Just I changed my physical servers, so IP numbers got changed. I don't have any domain URL, so I want to give that IP number and port number to them. So you need to give that new changes to all your clients so that they will adopt that change and they will do the checking. So it will be very difficult if you imagine your application is very big. If it is having hundreds of microservices, giving this many URLs, exchanging this many URLs to them with IP port or direct domain URL to them is not a good practice, and maintenance also will be very difficult. Instead of pointing directly to your dev URLs or SIT URLs or UAT URLs, what you can do, you can put a mediator between your clients and your backend here. Guys, I'm getting a lot of echo. Yeah. So you can put a gateway here. You can put a gateway here. So gateway can redirect. Gateway will run in one port number. It will be having its own URL. Okay. So let's say if you are running in one host plus port number you have here, gateway application. You can integrate all your URLs into gateway. You can integrate all your URLs, 16 URLs or 100 URLs or 1000 URLs. You can put all your gateway URLs. You can put all your application URLs into gateway, and you can exchange this single gateway URL to maybe for each environment. If you have separate gateway, for each environment, if you have separate gateway, you can give that gateway URL here. Maybe let's say if you have four environments, for each environment you may have one gateway, so you can share that four gateway URLs. Four gateway URLs you can share them. So now your applications side, you can have 16 URLs or 100 URLs or 1000 URLs. You need not to bother. Any number of microservices you can have. You just share your gateway URL. Now, when they want to communicate with your backend services, let's say if they want to communicate with the dev, maybe they will use dev gateway URL and they will make a call to gateway server with the subdomain. Let's say gateway URL is something host comma port. Just by giving host comma port, gateway may not understand which backend service need to execute it. Maybe you can give that prediction here, maybe a path here which is recognizable to gateway to understand which backend service need to be executed. Let's say admin service if you want to call. Maybe if you put admin path here, and in the gateway we can configure in such a way, if anybody requested with slash admin, if anybody requested with slash admin with any extra URL conditions it can have, you may redirect it to admin service. You can keep your admin service path here. Admin service, maybe dev path you can configure here. Dev service path you can give here, or admin service name you can give here. Let's consider path. Actual path of service you can give here. So as soon as somebody requests here with this path, gateway recognizes okay, he is expecting to call admin service URL, so it will redirect your request from here to here. Just it will behave like a mediator or a filter. First it will get request here, from there it will redirect it. So now onwards for your front ends, there will be single point of contact to call your backends. In case if you do changes to your URLs, you apply that changes here in the gateway. You need not to even inform to your front ends. Front end side, the prediction will be same. Slash admin they will call, and for that slash admin actual paths, if you want to change, go to gateway and do the changes there. So that changes will be reflected in the gateway, and gateway will recognize as soon as admin path request it is getting from the front ends or from mobile UI or any REST client, it will go to the actual path whichever you changed, and it will make a call to your backend microservice. Okay, so gateway here, the advantage is we can give a single point of URL to the front end teams to integrate with our backend microservices. There will be not much confusion to them, right? When you exchange so many URLs with them, there will be a lot of confusions. So during the maintenance phase or during the development phase, properly they need to put all the URLs, and they should make properly calls. Not only that, the problem is without gateway, if you give direct URLs, right? Not only maintenance problem, not only maintenance, not only maintenance problem here. The problem is, the advantage is maintenance is easy, and we can centralized security logs kind of things. If you want to centralize anything, right, you can centralize them here. In case if you want to apply security directly, if you allow them From here to here, the call if directly going, you can't centralize the security. If you want to apply security in one place, thereafter if you want to release the call to backend microservice, we can't do it directly. When you give you know URL to front end teams, and if they call directly in each and every microservice, you need to write your security logic or algorithms there. Instead, you can put a security filter here. You can write inside a gateway one security filter you can write, and you can check in that security filter. All requests will go to your filter only. All requests will go to your security filter only. So there you can verify whether that user is authorized user or not. If he is authorized, then you can allow that request to go to backend, or else from here itself you can decline it. So you can implement filters here. You can implement filters here, filters for security, filters for logging. In case if you want to do any centralized operations, you can do them from here before proceeding request. Generally in monolithic, forget about Kibana or other infrastructure which you have. Generally when you want to log, how we used to log in monolithic, we used to create a log file. In that log file, we used to generate all the log.info, whichever info we put within our application classes, that logs will be loaded. Now, as we have multiple microservices, across microservice, across your microservices, if you want to put logs, you can put, if you want to put local logs, you can put local logs. Local logs will be created into local log file. Okay, dev logs will be created into dev log file, SIT logs will be created into SIT log file. And again, for each microservice, you will be having separate log file. In case if you imagine, if you don't have any centralized log, for each service there will be one separate log file. In case if somebody make a call from here, and that call going to admin service from, let's say it is in production, so it went to admin service, from admin service to internally it is having one more dependency of seller. So one more call went to seller, seller to manager, manager to customer. Like that your request is spanning or going across multiple microservices. Somewhere it got failed, so I'm doing local logs here. For this one I have one log file, for this one I have one log, separate log files I have. So understanding the problem is difficult. When somebody reported there is a problem, I need to go and read this log file. And if there is no issue, I need to go to the next file. I need to go to the next file and next file, and I should identify the problem from where it is coming. So instead of having local logs, we need to centralize these logs. If we have a log server separately, if you have a log server separately, if you create a log service separately, from here, whichever you want to log, you can log it into one single log service. You may connect to separate service, and there you can do the logs. So when there is a request to admin log will be created in same file. Seller log will be created there. Manager log with all the timestamp and all in a single log file. If you can, add that, when there is a problem reported, I can directly go to that single log server. I can able to read the log and I can understand the problem, what happened easily. So I'm saying instead of doing log, yes. So in case if you don't want to put logs here during exceptions or in any scenarios, right? Generally before, after we will write before request, after request, right? So in case if you have such request based logging only, if you want to apply, you can put that log here. So while going request, as it is a filter, right? As per filter pattern, how it will execute before carrying your request to backend, and after execution of your backend, the request again will come back here. So if you put log here, all the logs will be recorded. In case if you have any exception scenarios, if you write a global exception handler here in the gateway, when there is an exception also will be thrown back here. So that exception also you can record here. It's up to you. Very, here I have so many private methods. Inside private methods also I want to do the logs. There is only one call going to the backend, but in the backend it is executing multiple helper methods. There are 5 6 helper methods executing that methods also I want to log. In such scenario you can use centralized log back or something, like as you said Kibana service, whatever you have, you can integrate with your log services, and there you can record your logs. In case if you want to request going to your backend, coming back from the backend, if you want to log, you can log here. Hmm. Yes, as you are requesting to admin service, admin log it will create. If somebody, it depends on the filter that you have implemented. Okay. In case if you want to log all the backend services, you can log there. If admin service request going, yes, yeah. If one gateway you are using for admin, seller, manager, customer, for four modules will be logged here. Depends on how. Correct. Huh. Seller, manager, and customer also. So that's where here REST clients also, right? Yeah. As I was mentioning, your REST clients also. In case if you want, if you have dependency between your microservices also, you don't call them directly here. You need not to call them directly here. So even you need not to have such dependency. Let's say in admin service, if I hard code seller service URL, in future seller service URL got changed, again I need to go and change my admin service URL here. So instead of I do calling directly, I should call via gateway only. Even my microservices also, if they want to exchange calls between them, admin should go back to gateway. Via gateway, it should call seller. Via seller only, via gateway only, seller also should call the manager. Via gateway only, manager also should call your customer. For everybody, the single point of contact is gateway. Yes, it can be your front end or any. Yeah, so everything will be centralized here. That is what. If you consider this gateway is a single point of contact, everybody should come here first, and from here they should go to backend services, whichever service they want to execute. Okay. Yeah, all your REST clients also, REST clients or SOAP clients, whatever you say, even from service to service also. Consider multiple teams if they are working. Okay, they need not to talk with you and tell that this URL, so and so URL I'm using, you use this URL, I'm going to change it in future, then I'll communicate it. Need not. Okay, maybe some customer service team working on the customer service, they will put all that customer service URLs in the gateway. Okay, so as an admin, if you want to call customer services, you visit gateway and see what all URLs have configured, and what is the root URL he configured for it. As you are talking, right? If we use Azure gateway or AWS gateways, when we need backend service URLs, we will visit the gateway. In gateway, they will show us, they will provide us a encoded URL, you say, or a new URL which is mapped to this actual URL. That URL will be provided to us, so we will be using this URL to call the backend services. So your REST clients will be using something, gateway URL slash admin slash something, post, get, put, delete, whatever URLs you have, you will call them. Gateway will take care internally redirections and all. Gateway will forward to your backend service, and it will execute, and it will bring back the result to you. Okay. Yeah, you can. You can have again third parties. Now, earlier we used to use single server, single file, there we used to put everything. Now we have lot of infrastructure. For logs we have a different separate infrastructure available. In case if you want to do local logs code, you can write simple log dot info, log dot error and all, and you can integrate your logs with the server instead of local file. In the log configurations you may integrate with the log server. So instead of placing logs into the local, it will connect with your log server, there it will place your logs, something like your log file in the local itself. Security also, instead of writing your own algorithm here, instead of getting username password and checking whether that username password in the database or not, if exists then only redirect, or you may decline the request here. You may use third party libraries and verify via that libraries whether the user is authorized user or not. If authorized, then only you can redirect. Anything if you want to centralize, you go to gateway and do it there, because it is the single point of contact. Yeah. Mhm. Yeah. So that is a, yeah, different infrastructure altogether. Kibana service URLs, if you configure here in this gateway, so obviously these logs, whatever you are writing, these logs will go and sit there. Okay. Yeah. So if you have something log back service into log back, Azure log back, right? You can, your logs will go and sit there. Yeah. Mhm. Yeah. Yeah. Okay. So here your REST clients are calling some backend services, and you are using gateway here. So the gateway is providing gateway URL. Via gateway URL, when you call gateway, gateway will actually make a call to actual URL of your backend service. Yeah. Hmm. Yeah. So yeah, so gateway will play such an important role. You implement your own gateway application, or else you use third party gateways like Azure gateway, or any other gateway services if you use, right? Like Apigee or APIM. Okay. So there the backend service people will register their URL, and it will produce one new URL. That one we will exchange with the front end teams. So front end teams always will call to the gateway. Gateway will make a call to your backend. So it will play a very important role in the microservices. Okay. Yeah. So to implement that gateway, in case if you want to implement your own gateway, it's not difficult in Spring Boot. Just you need to add a gateway dependency here. Just you need to add Spring Cloud gateway dependency, Spring Cloud starter gateway you should add here. Okay, just one single dependency, like how you added Spring Cloud config server. So you can consider this is like a gateway server. Okay, so for gateway server you need to add Spring Cloud starter gateway, and now it will start behaving like a gateway. Just you need to enable gateway here. We'll talk about Eureka later, but yeah, nothing here to enable. Yeah. Enable gateway also not required. Eureka not required for now. We'll talk about it later. So just add gateway dependency, and in your application properties file, give all your routing or mappings here. front end to back end, how you want to map. Actually, this is the predicates. Predicates will come from the front end. Let's say if web app is calling host and port of your gateway slash admin slash some create request or update request or delete request, if you fire here, first that request will hit to the gateway. From here, gateway need to route to your backend service. So as soon as I get this request here, gateway will see actually load balancer configuration URI configured here. Via load balancer I was getting it. In case if you have load balancer, you can give direct path of your application. As my load balancer knows that what is the admin service URL, it will help me there. In case if you have load balancers, generally we configure direct URL here. So what it will do when there is a request with the admin, so it will take to admin URL. If there is a request to customer, it will take to customer URL. If there is a request to manager, it will take to manager URL. So just it will behave like a mediator between your front end and back ends. So for logging, I implemented a filter, a simple filter I implemented using global filter class. So just it will provide a filter method to you. If you remember, if you know servlet filters concept, it is similar to that. Always filter will execute in between requests going forward to service and giving response back to front end. So filters will execute in both the ways while sending the request to the backends and while getting response also from the backend. It will execute in both the ways. So here this filter is executing, global filter executed. So it will execute before executing all your request, and this statement will execute after your services execution. Okay. Here when you call filter chain dot filter method, actual call will go to the backend. So this line number 20 will make a call to backend, backend services, and finally a response it will bring back. If you don't want to manipulate that response, as it is, you can return it. In case if you have any requirement to check that response, you may check it. Okay, via this filter chain, uh, I mean this exchange object, you can get or you can introspect your request also, whatever data you are getting, get application context, get attributes, whatever data you are getting, that all you can inspect here. But don't do any modifications. If backend teams not aware of, or if backend teams doesn't have any requirement you to modify, don't do any modifications. Just implement your logs here or security here and allow that request to go back to backend services. That's it. A simple dependency you need to add, and you need to add all your predicates here. That's it. Okay. So tomorrow I'll show you this example with Eureka. Without Eureka also we can run. Okay. Which one? Configuration. Yeah, we will implement it from the scratch. Okay. We will implement one filter after discussion of Eureka. Okay. I'll configure all together. Gateway Eureka config with your backend services. Two services we will implement, and we will make a calls between them via gateway, and one front end also will take. Okay. Yeah. 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 Others, do you have any questions? Yeah. Go ahead. Correct. Correct. But why you want in gateway you want some properties? Acha, acha, acha. No, no, no. I got you. Yeah, yeah. So you want that REST URLs also there? Yeah, of course. Again, this one can behave like a client for config, of course. Yeah. Our question is, yeah, nothing required. Same. This one also should be config client. Gateway can be, a config client. So in gateway, just you need to add this cloud config client dependency, right? This dependency you can add, and in that properties file you can put this import, config import. So it will make available your URLs also here in case if you want. Same configurations. The gateway configurations you might have centrally. So that configurations it will load here. Instead you doing it locally. Yeah. You can play with it. Okay. You put all this configuration stuff later this example, right? You may keep all these configurations, gateway configurations also from config server. Okay. And from there it can load. You need not to hard code them within your local repo itself. Maybe in future if you want to do modifications from that configuration service itself, you can change all these predicates, or application names also sometimes change. So you can do all such changes there. Some applications may have load balancers, some applications may not have load balancers. In future if you migrate your direct paths to load balancers also, you can configure load balancers there. Okay. So yeah, once the raw concepts you understand, right, you can apply all that to uh, we can integrate all that together and you can play. Okay. Okay. Yeah.